So, today we want to talk about a very simple group of organic molecules called hydrocarbons. Hydrocarbons are the simplest organic molecules. Hydrocarbons are only made up of, you guessed it, hydrogen and carbon. Hydrocarbons contain only carbon and hydrogen. The simplest hydrocarbons are called alkanes. This actually comes from Arabic. Alkanes are carbon and hydrogen compounds with only single bonds. So this means that all of the bonds with only single covalent bonds. So these are the simplest hydrocarbons. They are sometimes called saturated hydrocarbons, and you've probably heard that word related to fats. Saturated fats are fats that have all single bonds. Unsaturated fats are fats that have bonds other than single bonds, things like double bonds. We'll talk about those later. Carbon has 4 valence electrons. And again, remember, we show that by a Lewis structure where we use dots to show the valence electrons. Since carbon has 4 valence electrons, its most efficient way to become more stable is to share 4 pairs of electrons with other atoms. And if hydrogen is the only atom available, what carbon does is share 4 pairs of electrons with 4 hydrogen atoms, and that generates the simplest hydrocarbon. That hydrocarbon is called methane. So, for future reference, anytime we see the letters METH in any chemical name, that is referring to one carbon. Okay, that'll become more clear later. So methane is the simplest hydrocarbon and generally considered the simplest organic molecule. Organic chemistry is the chemistry of carbon. Well, one of the amazing properties of carbon is the fact that carbon can form bonds to itself. So if we want to create the next most simple hydrocarbon, we pop off a hydrogen, we add a carbon, and now we're going to represent the double bonds with sticks. Here is the structure of the second most simple hydrocarbon, and that is called ethane. So just like meth means 1, guess what F means? F means 2. The formula for ethane is C2H6. Wow. We continue this process, sort of like playing with pop beads. We get up to 3 carbons. We pop off another hydrogen, replace it with a carbon, fill in all the available bonding spots with hydrogens, and now we have a different molecule which has a formula of C3H8, and the name for that molecule is one that you might be familiar with. It's called propane. Anytime we see the prefix prop in a molecule, that means 3 carbons. So propane has a formula C3H8. Wow, there's a nice little progression here. We went from methane, CH4, to ethane, C2H6, to propane, C3H8. There's a nice pattern here. This group of molecules are called alkanes. Notice that their names all end with the prefix A, N, E. Okay, so one of the interesting things here is that we look at the end of the name to get the most general information. Ane means a hydrocarbon with all single bonds. Great. There's a beautiful little mathematical relationship between the carbons and the hydrogens. If you explore this, you can see that alkanes always have the relationship, if N is the number of carbon atoms, 2N plus 2 is the number of hydrogen atoms. So you can see that works for methane. If carbon is 1, 2 times 1 is 2, plus 2 is 4. If carbon is 2, 2 times 2 is 4, plus 2 is 6. If carbon is 3, 2 times 3 is 6, plus 2 is 8. It works just great. So if we move up to the next alkane, we know that 4 carbons is going to have a formula C4. 2 times N is 4, is 8, excuse me, 2 times 4 is 8, plus 2 is 10. So the formula of the next alkane is going to be C4H10. And now something pretty interesting happens. We can take those carbons and we can put all 4 carbons in a row. And after you play this game for a while, you realize that the hydrogens are really peripheral. Hydrogen only has 1 valence electron. Hydrogen only forms 1 bond. Hydrogen is always on the outside, therefore. So we draw in those 10 hydrogens. It gets a little tedious. We draw in enough hydrogens to give each carbon 4 bonds. And after a while, you get tired of putting all the hydrogens in. So experienced chemistry students, as you are becoming, okay, first of all, this molecule is called butane. Anytime you see the prefix but, it means 4 carbons. And its formula is C4H10. After a while, however, we get tired of putting all those hydrogens in this. So we've got a couple of ways of representing it. First of all, we can use something called the condensed structure. So if we condense the structure, instead of drawing each of the hydrogens, we kind of condense it. So that's the first carbon, and connected to that first carbon are 3 hydrogens. Here's the second carbon. Connected to that second carbon are 2 hydrogens. Here's the third carbon. Connected to that third carbon are 2 hydrogens. And finally, connected to that fourth carbon are 3 hydrogens. So this is called the condensed structure. The condensed structure, very nice to be able to do in a word processor, as long as you've got a, oops, I'm really messing up here. As long as you've got a subscript button. The condensed structure shows all of the atoms, okay, but it shows them in a condensed form. A favorite among really experienced organic chemists is the skeletal structure. In the skeleton structure, we represent carbon-carbon bonds by a line. So if I start to draw this, here's a line that represents, oh boy, here's a line that represents the first carbon, the carbon bond, the second carbon, the carbon bond, the third carbon, carbon bond. So carbon, 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 carbon. Every place where the line bends, or at the end of the line, represents the carbon atom. This is called the skeletal structure, and it is the ultimate shorthand that experienced chemist knows. So the reality is that as a person who's becoming more experienced in organic chemistry, you should be comfortable with all 3 representations. The total representation up here, which you sometimes call the complete Lewis structure, the condensed structure, and the skeletal structure. Okay. Now, something interesting happens once we get up to 4 carbons. There is another way of putting the 4 carbon atoms and 10 hydrogen atoms together. Perhaps you figured this out already. And if we look at that, instead of putting 4 carbons in a row, I can put 3 carbons in a row, and then branching off the middle carbon, I can put the 4th carbon. If we fill in all the hydrogen slots, there is our total Lewis structure. And if we count up all the carbons and hydrogens, notice that this structure has exactly the same formula. It is C4H10, but it has a different structure. Molecules that have the same formula but different structures, try to write more clearly, structures, same formula, different structures, are called isomers. Isomers are compounds that have the same formula. So in this example, C4H10, but they have different structures. Wow. Now, here's what makes organic chemistry so interesting. It only takes getting up to 4 carbon atoms and 10 hydrogen atoms when you begin to see isomers. There are 2 different ways of putting together C4H10. Obviously, as you get up to higher numbers of carbon atoms and hydrogen atoms, the number of isomers dramatically increases. Okay, so it's really isomers that make organic chemistry such a rich and diverse field. And it's organic chemistry the chemistry primarily of carbon and hydrogen that gives the covalent category so many more compounds than the ionic category. Okay, we're going to stop here, and in the next session, we'll look at more complicated, quote-unquote, hydrocarbons, and we'll talk about how we name them. Okay, great.